Hello everyone, I'm Professor Mark Baines with Concordia University, and today in Exercise Physiology we're talking about exercise physiology as it relates to fatigue, exercise testing, and other performance factors. This will be week 9 in our course, but of course the information is applicable for anyone in regards to physiology and performance. That said, we're going to go right into some concepts that we've talked about in the past to get some greater clarity. Make sure when you're testing in general, no matter what you're testing for, whatever sport you're looking to increase performance in, that you're using movement-specific tests. Many students have actually referred to using the modified Canadian test for assessing cardiovascular capacity or aerobic capacity, VO2 max. There's a Wingate test for cycling. There's swimming tests as well. There are actually even ice hockey skating tests you hear less about because they're less needed unless you're talking about ice hockey. Another common one people have used is the treadmill for doing treadmill tests as well. If you have land-based athletes, if you're talking about track athletes, if you're talking about basketball players, you're looking at football players, less needed for aerobic testing for football players, but certainly soccer players, any sport where there is a significant amount of time spent on the ground and you're going to be going for longer periods of time, you have some needed for aerobic capacity. Even wrestlers and fighters are in this category to some extent. That said, you need to be doing a running type test on the ground because that's going to be the most applicable to the actual performance. Less or so for your fighters and whatnot, but still, I'd much rather them on the ground than on a treadmill or doing the modified Canadian test, which is fine in situations where it just fits your environment, it's just easier to do for you. Okay, if you want to qualify it as it's easier for you to do, that's fair. But if you're going to qualify it as it's a more predictive test to actual performance, no. So you want to find the most predictive tests toward performance because that's what we do as coaches. So please take that into account whenever you're determining tests that you're going to use for any performance factors you're looking to assess. The 300-yard shuttle test is a frequent test that's used for going back and forth or frequent direction changes over the course of a 300-yard essential run. If you're not looking at basketball players, football players, soccer players, anybody who's running back and forth, changing a lot of direction on land, I wouldn't use that test. I'd use some derivative of a different type of test for assessing anaerobic or lactate threshold, which we'll come back to talk a little bit more later on. But it's a fair test. Is it applicable to what sport you're working in? You always need to take that into account. If you're a strength coach, like a few of you are, whereby you're working with varieties of athletes and varieties of sports, if you have the option, you want to try to make that test more specific to their sport. If you have no options, you're just trying to look at some way of assessing, and it's just what you've got. Say, I know this isn't the absolute best test for each specific athlete, but it does make sense for my situation, and that's fine. Of course, I'm going to challenge you to think about, well, do you really have the ability to get all your kids to go outside? Actually, the easiest tests are some outdoor tests because you don't need equipment for a lot of those tests. But weather might preclude that. A lot of factors can play a role, and it's worth noting that. And as far as how often you assess, on the earliest, probably is 4 weeks. Even 4 weeks, really what you're looking to see is not a lot of change necessarily in aerobic capacity, not a lot of change in strength, but you're really looking at changes in either hormonal response, maybe they've been well rested, maybe you're just looking early on, early season, or we should say preseason, off-season. Every 4 weeks might make sense. During season, of course, your actual competitions will serve as your assessments, but you're going to do that less and less often as the year progresses or as you get closer to your actual time of competition, because at that point you're going to have the competitions being the assessments in themselves, and you can't tire your athletes out with some assessments. There's some assessments you'll still be able to do if you're looking at certain types of players that have needs across the broad spectrum, like the basketball and the soccer type players, where you're doing a little of everything in your sport, right, or any similar type sports. That will probably have frequent need for adding some other tests in there, even in regard to the competition time frame. You might still do some agility tests in addition to basketball, because you don't like enough fatigue an athlete with an agility test or a vertical jump test, things like that. But you probably would limit your aerobic tests, capacity tests, or your anaerobic threshold, lactate threshold type tests during season for those kinds of sports, because they're getting so much stress already from that particular performance standard. Okay, but do the best you can with recognition of timing-wise, what makes the most sense for your athletes, and alter it. But any more than 12 weeks, you're not going to get an accurate indicator of what's going on. It's too long of a period to assess. And anything less than 4 weeks, it's going to be hard to see any changes in anything other than they're more rested, or maybe they've been eating better the last few days, maybe some slight neural or nervous system response changes, but not a lot of major changes. You can always do it more frequently or less frequently, but please understand what that's going to mean when it comes to your assessing. Okay. As far as training goal specificity, It's all an aspect of strength. Everything we do is an aspect of force output, whether you're talking about power, strength endurance, cardiovascular type endurance, which is an aspect of more general endurance versus localized muscular strength endurance, right? Either way, we're talking about training goal specificity. Make sure we're training to that. You're going to have some combinations for some athletes, like we mentioned before, some sports that require multiple aspects of aerobic capacity, anaerobic type threshold, and agility, speed, power, strength. Any of those factors, or there's combinations of, your training goals are going to be wide and varied, and you got to look at the best that you can toward either positions in certain sports or toward each individual athlete, how they're responding. Best case scenario, obviously, if you have the ability to alter each individual's program, well, then you do. If you just can't, it's not feasible to do so, it's not reasonable to do so, you do the best you can, generally speaking, right? But that said, make sure it's specific to each individual performance goal you're looking for, and you have to constantly evaluate the changing needs of your athletes. It can't be all year round that the primary goal is going to be agility or speed or strength or whatever it might be, because you're going to see them altering in their abilities, maybe they're getting lesser or more benefit or value there and increasing in certain levels of performance where they're not in others. You may alter those goals too. You have to always be looking at that, probably at least on at least a quarterly basis, but probably more likely a monthly. And therein we have the 4 to 12 week time frame for assessing as well. Good important point to note is that proper use stress, giving the right kinds of stressors, can basically counter distress. You can't always control, well, you can't control inherited or biological factors that people have. You can't always do a lot with environment, but you can a little bit. You can alter situations where you're in with the temperature being different, time of day with light and dark, that kind of stuff you can alter to some extent. But that said, we have a lot of behavioral options we can help with. And the fact is, a lot of our athletes, if you're looking at that junior high, high school, college, there's always some aspect of peer influence and what's going on in their social lives, what's happening with them in regard to their parents and their families. True for adults as well, but particularly more so, of course, for the younger athletes or younger teens and sub 21-year-old kids. This is a lot more of a predominant focus point for them. You get more work stress as they become adults, right? There's the work life, not just the school life that they're looking at. There's always those stressors, and you have to take those into account with athletes the best that you can in talking to them about how they're dealing with those kinds of stresses, which a lot of you do a great job of talking about things you do with helping your athletes cope with those kinds of things. But you also then can't increase the risk in the performance during practices with adding more stress to them if you have the ability to control such things. And if you do, you have to lower those kinds of stressors, increasing the rest, lowering the intensity, force output wise, lowering the work periods wherever you can, doing less sets when you can. Although if you think it's controllable, and you think there's things that they're doing that they're not doing a good job of, you have to relate to that fact to them. They need to be doing a better job outside of practice, outside of games, to control those types of stressors and work with them somehow in that regard. But you can't just add stress and say, tough luck. Sorry, your life is stressful. Today's a hard day. A lot of coaches have done that in the past, and the results are never good. They're just not. It doesn't teach anybody a lesson. It just teaches them to have a lower performance, or it forces them to have a lower performance. That's not the goal here. Okay? Potential versus development of risk. There's always the potential for risk. Everything we do is about risk and benefit, right? And if we're always looking at risk versus benefit, this is a very stressful type exercise training day. Well, if the risk exceeds the benefit probability based upon the person's readiness for a given day or the group's readiness for a given day, then the risk is high and we lower that stress. It's just that simple. When it comes to any isolated exercise, if risk is high and benefits are not equally as high or better than the risk, we don't engage in that exercise, regardless whether it's a good exercise or it's a fun exercise or it's challenging or whatnot. Risk versus benefit. You must always weigh those options. Okay. Maximal efforts are going to be only attainable in certain specific situations. They have to be rested clearly. They have to have eaten well. They have to be focused on mentally being ready for a performance. A lot of coaches, and we've all had these coaches, yell at you on a regular basis because they know that sometimes when you yell at people, you can get a better positive response. It kicks their rear end into gear, so to speak, and they get going. But if you dip into that well on a regular basis and yell all the time, you're not going to get a competitive level performance. It's just not going to happen. If you don't usually yell and one day you're, come on, go, and going crazy with your athletes, well, then they might get a better response that day. If you recall looking in your chapter, in your text, talking about specifically, they've shown that sometimes the addition of a certain voice at this perfect timing, saying the right thing at the right moment can elicit a top-level performance and a competitive level performance. That's true, but that's really unusual. You can't do it very often. And the fact of the matter is, in 90+% of situations, you're never going to fully mimic a competitive level situation unless you have tremendous time and control, or like you've done in some laboratory situations. They take individual athletes, have them meditate and focus and go through a whole process of mental preparation over minutes and maybe even hours, and then get them fully relaxed and focused, and then go boom for a high-level maximal jump or maximal lift, or something that's very short burst, by the way, not going for a long run now, expecting a highest level performance, but something like that they've actually had great results with. That's difficult to duplicate, but it's absolutely true. You can absolutely behaviorally affect performance in so many ways that all, however, requires you to understand you can only do that so often. So don't expect to just constantly look for that perfect moment every time, all the time, to get the best response, other than the best response you can at a given moment. Okay? But maximal performance, it's going to be competition situations, most cases. I know it's been said before, but I want to reiterate a few points when it comes to American College of Sports Medicine's expectations for exercise. If you're looking for someone just to maintain health, we're looking at 30 plus minutes per day average of that moderate level intensity, for sure, at least half that if you're looking at vigorous intensity or more higher intensity type activity, which again, as we should now almost be able to just cite offhand like that, above 60% VO2 max. We're talking about cardiovascular work / above 75% max heart rate. Doesn't mean we try to pursue that heart rate that high. It's just a reminder it's probably going to be there when they're engaging in that 60-70% force output level for longer durations of activity. That's what's going to happen, okay? And we should now know, and I've said it numerous times, make sure we know this, there's just not a chance in you-know-what someone's going to get more than 65% force output maximally when they start engaging in activity that's maximal effort, level 10 RPE, for 15-20 minutes or more. You're going to drop down to 60-65% of your max force output, maybe less than that. You just don't have a choice. Now, you may be more elite conditioned, and maybe your force output's a lot higher than someone else's, or your athlete's performance level is a lot higher than someone else's. That's the goal. But you're going to lose performance output. You have no choice, okay? Despite your despite your perception of your level of effort, okay? That said, for someone who wants to at least be fit, we're looking at an hour plus average per day of moderate level activity, or at least 30 minutes per day of vigorous activity, intense activity. And of course, you're going to actually go another 50% above that, 1.5 hours or more on average every single day for moderate level activity, or at least 45 minutes per day vigorous, high-intensity type activity every day of the week to achieve more athletic type performance, which is the reminder, if they're an average athlete or average person, they're going to be in that category. If they're above average, they might get away with a little bit less. They're trying to maintain something, or if they're already at elite performance level, just trying to make small incremental changes, they might be able to get away with less time. More than likely, most athletes have to go beyond that, go higher than those numbers to achieve significant improvement in any given training variable area, okay? How do we avoid fatigue? We've kind of alluded to it so many times. I know we've talked about it in the past. Your 4 primary life factors you can control. You can control what you eat, what you eat and drink, what you ingest into your body, your sleep. To at least a certain extent, you certainly can, right? A lot of people like to say, I don't need to control when I have to go to bed. I have work to have to do. You still can control it. It's still a question of work versus sleep, and that's a decision you have to make. You understand that whatever choice you make, something gives. As long as you can acknowledge that, then we can deal with it better. But you do have control, and that's ridiculous to say you don't. Certainly when you have kids, which I do, you can go to bed at a certain time. Doesn't mean you're going to be guaranteed to sleep the whole night through, because you don't have much of a choice in that regard. But to a certain extent, you can control it, right? The best we can with what we've got. There's eating / nutrition, sleeping, your life stress. Now, you can't control everything that goes on in your life around you, how people respond to you, but you certainly can control how you respond to others. So we have the ability behaviorally to affect our life stress, right? And of course, how we engage in exercise can greatly affect that. So it's exercise, life stress, nutrition, or our eating habits and drinking habits, and sleep. We have those 4 factors to play with, and we do whatever we can with any one of those 4 factors to alter our stress levels for the better, for the benefit versus the risk. So if we don't have control over certain areas, then we have to exhibit greater control in other areas. And the one you have the most control over for your athletes is the exercise. and it can play a great role with adding new stress and avoiding distress for your athletes. And of course, the reminder that kind of slowly get to the point where now you should be able to do pretty well with any given performance parameter of talking about frequency, how often you do something, what the rough intensity perception is for or effort is for a standpoint of RPE versus heart rate versus force output versus VO2 max. Reminding you for the umpteenth time, VO2 max really shouldn't be discussed. It's in the textbook, but it confuses things a little bit because VO2 max has to relate to aerobic activity. So when you talk about percent VO2 max and we're talking about glycolytic or 30 to 60 second work periods, sure, heart rate wise is consistent with a given VO2 max, generally speaking, that we talk about if we're talking about endurance type activity. But really, your VO2 max, your effort is well above 100% VO2 max for anything that's like 2 minutes in or less for all out type efforts on a given set. Okay, so I wouldn't even refer to VO2 max when it comes to 2 minutes or less activity. I know you're on the textbook refers to it that way, and it's kind of confusing, but I would refer to heart rate expectation no higher than blank, and certainly force output expectation and RPE, and VO2 max saving that more for the endurance type focused activity. Okay, type or tool you're going to use, time, you should be able to do almost by rote. We talk about power or strength or speed versus hypertrophy, glycolytic interval type training versus aerobic activity. What are the general work parameters of that now? You should be able to do that. We've done that, shown that in previous units. And of course, rest and recovery based upon the ATP replenishment requirement for the force output requirement. You should be able to break that down pretty straightforward too. If you have questions on that, email me, call me, either way, we'll clarify that. You need to have that down. You really need to have that down by the end of this course. So much so that it's imperative. It's probably the most important things, and you're going to get more and more test questions on that as well. And of course, lastly, rate of progression. How do you progress someone? Well, on a scale of 1 to 10%, additional challenge, if you will, on a given week at the very, very most. Okay, 10% is a big jump. Honestly, jumping 10% is a big jump. That would be only if someone's shown some monumental improvement somewhere that we add 10%. We do this every day though, or every week all the time. We think we're doing small changes with people and it's 10% plus. When you to shortcut the work period or rest period from a minute to 30 seconds, that's a 50% change. I wouldn't do that. I wouldn't do that. I would actually only take a little bit off there, short, slow changes, or expect a much more significant drop in force output, which if that's okay with you, you can shortcut that rest period from 60 seconds to 30 seconds. But you've got to expect a huge drop of more than 10% in force output in most situations. Okay, so we have to weigh those options. Not more than 10% variable change in a given week, probably a lot less, closer to the 1%, small changes somewhere in our programming or how we alter what we do. But please, and this has been said before, don't make change for change's sake. We have to change things up for athletes. Based on what? Psychologically, if you're saying, well, I can tell that right now they're not into this, they're not focused. Fair enough, you're changing it because of that, but not because of performance parameters. If what you're doing is working, or if it's more specific to the activity that's required, you keep doing it, and you can alter some psychological variables, but don't alter the physiological variables. Be careful about altering physiological variables for psychological need. There's a difference there, okay? Detraining, within a few weeks, actually within 10 days, you can start to lose performance. You can actually, within a couple weeks, 10 days to 14 days, somewhere give or take, definitely within 21 days, can lose 5 to 10% of your aerobic capacity or your force output type level performance very quickly in 2 or 3 weeks. So for that reason, we try to avoid significant downtime. It can't always be helped. Neurally, we may not be we'll actually be losing capabilities first. And as far as muscular, that's what happens more of a process of time over several weeks. Right? You detrain, however, the positive is that you can get hypertrophy that you once had, muscle size, whether we're talking about type 1 fibers, type 2A fibers, or type 2X. You can gain back size of muscle fibers faster and more efficiently than you can your cardiovascular endurance, your VO2 max, if you will. It's not that type 1 muscle fibers don't adapt as quickly. They do, but the ability to actually perform at longer periods takes a lot more time to build back up than it does simple hypertrophy. And I can't remember which chapter it was exactly off the top of my head, but if we haven't specifically mentioned it, we're going to see it very, very soon. And I think it's actually in this week's chapters that within 6 weeks of hypertrophy training, return to it. Even after months off, you can return to what hypertrophy you had several months ago. Pretty impressive stuff. with proper training, clearly, and the proper programming and handling all those stressors properly. That said, doesn't mean it's always going to occur in 6 weeks, but as soon as 6 weeks, you could gain back what you lost. That's pretty awesome stuff. Cardiovascular capacity, probably looking at about double that if you've spent 6 months plus off that, or up to double that, I should say. Not necessarily, because there's always individual variables as well. But it's good points to be keeping in mind in terms of the recognition of detraining and also referring to regression, if you will, or training regression from falling back a little bit, being off in time from what we've been doing. VO2 max and lactate threshold, anaerobic threshold increase. Keep in mind, lactate threshold occurs before the anaerobic threshold. It's not exactly the same thing. The book notes that and yet says it the same way. It kind of confuses you sometimes. It's the difference between having 20-something chapters and a tremendous amount of information. It's not so much counter as much as it's not perfectly clear at times, but they are not the same thing. Your book notes that, but it's actually not exactly the same thing. Anaerobic threshold has to do with more ventilatory threshold and breathing, whereas lactate threshold is actually specific to the blood. An LT will occur first before AT does. That said, activities that are going to improve your VO2 max, you're going to have some improvement over your lactate threshold, anaerobic threshold, and likewise, the opposite is also true to a certain extent. Longer duration activities, 20-60 minutes is what your book refers to as at least 3 days a week, possibly more if at all possible, up to every day if you could, at least at that 40-60% VO2 max level range, and going upward from there when the person's ready to do so over time. Is going to improve VO2 max, or should theoretically improve VO2 max, up to 50% for deconditioned athletes, and only as little as 5% for those who are more conditioned. Keep in mind though, 5%, if you improve 5%, that is a phenomenal change. Okay, that's every 100 seconds. We're talking about, that's a 5-second improvement. A 5% improvement would be monumental. Okay, so that's actually a monumental improvement, even though 5% sounds awfully small. 50%, of course, is a monstrous thing. That's why it only really occurs for the people who are deconditioned in the first place. But using high-intensity intervals are going to improve your lactate/anaerobic threshold and your VO2 max. But steady-state runs, those working on critical power for longer periods, working at high-speed runs, whatever you can maximize your running speed for 20-30 minutes or longer in those high-intensity type days, where you're right around your anaerobic threshold, lactate threshold for long periods, that can absolutely improve the parameters of VO2 max and lactate threshold and anaerobic threshold as well, not just your high-intensity interval training. Okay. Now, that said, concepts for this week specifically, not just the stuff we talked about in the past. Your high VO2 max versus winning in performance. You can have a high VO2 max, which really high is referred to probably anything in the high 50s and above from a VO2 max aerobic capacity standpoint. You're going to be a pretty good athlete in some aspect of endurance, whether it be swimming or cycling or running, depending on what you perform regularly, at least for longer duration type activities, when you have that VO2 max in the high 50s, whatnot. The mistake that a lot of people often make too is in testing, they'll taught you, many of you talked about this, doing like a 1 mile run. 1 mile run? 1 mile run for a pretty good athlete is going to be a 5 minute, 6 minutes. That's not an accurate time frame for VO2 max. You need to be testing, and the book notes this, and this is rampant through all research, at least 10 to 12 minutes to get a true recognition of VO2 max. You're not going to get an accurate recognition of doing a 1 mile run, in some situations even a 1.5 mile run. In my heyday when I was running at a really high pace, I could run those 2 miles in around 5 minutes. So consequently, about 10 minutes in, I've run 2 miles. The Cooper test, which is a 12-minute test, a little bit over 2 miles in that time frame. But if you actually used my 800 time, which is in the low 150s back in the day, it would give me a VO2 max in the low to mid 70s. Whereas my actual VO2 max relative to doing a 10 to 12 minute test was more likely was actually in the low 60s. So that's a huge variance. You need to engage a long enough test if you're going to be testing VO2 max at all and expecting to use that as a reasonable estimation of someone's improvement in aerobic capacity. And actual general conditioning tests for general population is more like 10 to 20 minutes, but at least 10 to 12 minutes. None of this, I'm using a 1 mile run stuff. It's not going to be accurate, okay? You got to be doing something much longer duration to actually assess someone's aerobic capacity, all right? And of course, assuming that they do have a high VO2 max doesn't mean they're necessarily going to be the best athlete when it comes to endurance-related type sports or activities. It's simply as simple as the athletes who have the highest VO2 max in addition to other properties as it relates to performance, movement skill, having a strong lactate threshold, anaerobic threshold, having good basic strength, good flexibility, good mobility, all the factors of performance and a high VO2 max are probably going to be the winner. But you can't be strong and have good mobility, flexibility, and a lower VO2 max and expect to win. So it's not that high VO2 max means you're going to win. It's that you're going to need a high VO2 max if you're going to be the athletes that are performing the best in the fourth quarter, whether it be football, football, basketball, in the final round of a wrestling match, in fighting, same thing. Soccer, getting late in the second half, any of that kind of thing. Ice hockey, getting into your third period or second period, depending on what level we're talking about for hockey. Now, whatever you're doing, the longer that game goes on, the more important VO2 max and aerobic capacity has a role. And consequently, the higher that VO2 max, in addition to other factors, the better their performance. That's why it's a mistake to not put at least 10% or more of your efforts into VO2 max for any sport where clearly they're going for many, many minutes or more for some athletes. Okay? And of course, in testing, should be a 3 to 5 minute warm-up, followed by that 10, 12 minute test. And for elite athletes, they've seen plateaus in about 2 to 2.5 years. Doesn't mean that when you start doing aerobic activity in 2.5 years, you're going to peak. No, not necessarily, but that's what you're kind of roughly looking at if you did all things correct. And there are limits to VO2 max, in which case, once you do reach those limits with proper training over many years, then we have to look to other performance factors to improve, to keep seeing improvement in performance. Lactate threshold, or the onset of blood lactate accumulation, which occurs right before the lactate threshold. That burning sensation you start to feel locally in those muscles when you're approaching that lactate threshold. That's the point where you need to take a break. If you're looking at training for intervals in competition, we just keep on going. You got no choice. You got to win, right? But the ability or the improvement in lactate threshold / anaerobic threshold, or the longer duration you can actually go without seeing that onset of blood lactate accumulation, we're going to see better performances for someone who's engaging in activity of any kind, work, rest, or just solid work. Either way, for 12 minutes and beyond. Okay, if you're on the field for 12 minutes or beyond, if you're involved in activity consistently within that 12-minute period, a lot of basketball players, certainly the case, right? You're going to see performance improving when you can improve the lactate threshold. If you want to test for it, it's about a 2 to 5 minute warm-up and incrementally increasing the intensity every 1 to 3 minutes. There's a lot of tests you can possibly use for this. And of course, at the best case scenario, you're looking at about 30% improvement over many years. And to be clear, 30% improvement is monstrous, up to 50% with VO2 max, but even a few percent improvement can be a monstrous change, especially the higher level you get when it comes to sports. Critical power, it's actually is a slower rate of performance than you're going to get from lactate threshold. It occurs, the critical power point essentially is after lactate threshold. We're talking about something you can maintain steady state for about 30-60 minutes, give or take. And they say, research would say that it is indicative of performance for anybody who's engaging in activity for 3 minutes or longer at a fairly consistent level, okay, which is going to relate to a lot of sports, okay. And that's something to be considering, how to be performing steady state type activity for anyone who's engaged in constant activity for 3 minutes or longer, okay. Running economy, exercise efficiency, you're going to improve that if you can improve any of these factors we're talking about here. Movement skill, motor control, strength endurance, or hypertrophy. If you grow muscle fiber size, type 1, type 2A, type 2X, if you increase strength endurance, you increase muscular force output as a whole maximally, motor control, coordination, movement skill, any of these factors will improve exercise efficiency if it relates to the specific sport that we're talking about. Okay, and of course, one of the reasons we often encourage young athletes to play multiple sports is that ultimately what we're trying to encourage at a younger age is improvement in overall movement skill and motor control. So they engage a sport they've not played before, they have the basic capacity to be able to move quickly, to be able to change direction quickly, to have basic endurance, to have basic strength, so they can adapt with coordination of the sport, but ultimately they already have a lot of conditioning factors and movement capacity to be able to handle a lot of the stresses of that particular sport. That's why it's so important for at a young age for athletes to play a lot of different things, let alone for overall development and not overuse and creating overuse injuries. If you're seeing athletes at a young age, high school or younger, even college really, but certainly high school or younger, getting some serious stress injuries, not talking about impact like football, someone hits you, it's going to happen. Or other sports, you're getting hit by something or someone. But certainly if you're just running and you get hurt, Mild injuries or strains are one thing, but actually tearing ligaments, having a major muscle pull, having stress fractures, things like that, they should not be occurring. There's something wrong in programming, and probably programming for many years if that's what's going on, or it's some other major health issue we got to take more into account. That said, you can improve overall performance by actually increasing your movement skill on any of these factors by 15% or more over the course of a career. That's monstrous. And that's only starting recording someone, really all the research for this talks about looking at high school or collegiate type athletes and beyond, not so much young athletes and beyond. So you want to see more than a 15% improvement, doing more activity of a variety of nature in terms of movement-wise with younger athletes, no question about it. And a variety of performance factors, we should say. High-intensity interval training, we've talked about many times before. We're looking at engaging somewhere around 20 seconds. Yeah, it could be a little less than 20, but 20 is a pretty darn good number where you're out of the ATP, CP energy system range. Technically, to make sure this is clear, ATP, CP is involved at about 45 seconds as still a moderately dominant type energy system. Your glycolytic energy system takes over primarily around 15, 20 seconds-ish in most situations, maybe as high as 30. And then it becomes the most dominant one up to a couple, 2 or 3 minutes. But ATP, CP is still playing a role at about 45 seconds of a fairly high nature. And it drops significantly down, playing a very minor role after about 45 seconds of activity, okay? That's why you see a big drop-off from a 400-meter athlete to an 800-meter athlete, as an example. Among many, as you're moving from energy systems significantly, right? And likewise from an 800-meter athlete to a miler, or someone who's engaging in 1 to 2 minutes of activity versus a 4 to 5 minute activity, a long activity, huge drop in performance. And that's why, because you're moving through energy systems, right? Rest as long or longer is a good general rule of thumb for rest periods for high-intensity interval training. Please avoid ratios. I've become such a non-fan of ratios, and I've gotten after many of you on this. I'm going to keep after you on this. Counting reps. I've got to really question that. We've all been taught that. I was taught that. It's all I did throughout my entire career. Reps are based on the duration of time. The reason they say in strength or power 1 to 5 or 8 reps, somewhere in there, because it's indicative about how much work you can get done in a very short period of time. Okay, and that being said, you're better off figuring out how much time do I want my athletes to build performance high outputs and basing it on time. So here's that load. Can you handle it for 10 seconds or 20 seconds? Can you move it at all? Of course, that's maximal output. We're talking about the 1 rep max type stuff. Well, you don't count reps. Can you do it or can you not do it? Right? But that said, I'm going to highly encourage you to stop counting reps when it comes to things. And as a basketball coach, I never counted dribbles. I counted passes from the standpoint of making sure we're getting the ball around the court. We don't count that type of activity because it all relates to the general flow of the game. Completely disagree with how many footsteps you took down the court. Track, I count how many footsteps it took you running around 400 meters. That makes no sense at all. It's trying to increase your stride length unnaturally because you're not striding long enough. No, increase your strength, increase your overall flexibility and mobility. Those things will happen naturally. That said, it's too often accounted for counting reps in too much of what we do. Look at the physiology and understand the work period and the tempo at which you move. Then you'll get the right number of reps and not have to count them, okay? You have to always be thinking about how much force is required, how much ATP is required. Generally speaking, for high-intensity interval training, we're looking at 70 to 90% maximal force output. So we're looking at about 70 to 90% ATP. 70% of ATP is recovered in about 30 seconds in a lot of athletes, not all, a lot of them. And you're getting about 90% after about 90 seconds, close to 100% after 90 seconds for the elite of athletes. And that's why we always say 30 to 90 second rest period for high-intensity intervals, okay? That said, heart rate and RPE should now be something that is a part of your mindset after every single set when it comes to any repeated exercise or drill with your athletes. Everybody can just quickly go to their radial pulse and start counting within a few seconds. Let them all find it and go, do stopwatch, and tell them stop for 6 seconds. They add a 0 to it. That's the easiest way of doing it. I like to do it for short periods because if you go for longer periods, after the end of a given set, the longer you go after the set to take their heart rate, the heart rate's already going down. So consequently, you're not really getting an indicative number that's consistent with what level they were at for the activity. The closer you can do it to the actual activity, the more you have an indicator of what it actually is at the end of the activity, and of course how much you want to see it come down. As a general rule of thumb, we've said it before, we want to see you get down at least below 120 beats a minute before you engage in any high intensity type work. You don't want to ever see anybody try to engage anything that's supposed to be glycolytic or anaerobic power in nature with them still not seeing their heart rate getting down below about 120 beats a minute. Okay, you can, but I'm willing to bet the simple, obvious response. Their performance that next set will either not be as good, or they hang on and they have a great performance that next set. Then if you try and do that same little rest period again for the next after that, it's done. They spent themselves. Be clear that was your goal. If you only had one rep, one set left, you can always do that, but be careful. Make sure they perform at a higher level or the same. And of course, maximal anaerobic power or strength, we're talking about force times distance over time. To make it really clear, anytime you improve an aspect of force output, you're going to improve every aspect of strength to some extent. Some extent of strength endurance, some extent of strength and power and whatnot. But if you're trying to maximize speed or maximal strength, you either certainly have to increase force output, but more importantly, you're trying to do it in less and less time for speed and power, right? And of course, we're talking about 3 to 5 minutes rest, 95% 100% ATP required, so therefore you need 3 to 5 minutes. Your book confuses it several times, talking about like football players or any athlete similarly, going for a few seconds with 30 seconds rest and going again. That may be performance specific to the sport, but that's performance conditioning. That is actually glycolytic. That's what that really is. That is not 100% force output. There's no way on earth after doing that for 3 or 4 or 5, 6 sets or more, any athlete's going to be able to give you absolute maximal output. They're not. What you typically see in actual play, if you watch athletes in general who do this, when they go from one play into the next, they're either not the same if they get the ball again, okay, or they don't get the ball. They're involved in the play and they get the ball someplace else, so that person has a chance to recover to some extent in the play itself. They don't go toward the same part of the line in football. They'll give it to a different player. The quarterback will look to throw it to somebody else. Whatever the case may be at play here, they find a way within the game itself to kind of give them a rest, because no way on earth you get maximal performance. If that is your goal, don't rest 30 seconds, rest maximally. Just know the goal and don't call it power with a 30 seconds rest. It's not, okay? Hypertrophy, max force output, somewhere in that 70-85% max force output, maybe 65%, maybe as high as 90, but that's questionable. If you're trying to maximize hypertrophy, that's kind of your output range you're looking for when we're loading. And of course, anything you do for 40-75 seconds of work is going to maximize hypertrophy, particularly type 2A fibers. If we're trying to maximize size and response from size for overall performance, we're looking at type 2A fibers in particular we're looking at here, okay? And 60 to 90 seconds rest. Shouldn't need more than that. If you do, the performance level as expectation is too high. And a reminder of, if you notice between maximal power and hypertrophy, you never see more than 6 to 8 sets. Even then, there are not many athletes who can do 6 to 8 sets at those levels and maintain performance or improve over the course of sets. You don't have to increase weight every set, like sometimes they'll refer to in our text and other forms of training. First of all, if you're increasing in load per set or increasing in speed per set, you're still effectively kind of warming up. Honestly, what should happen with a proper warm-up, we should be maintaining the same level of performances with very small variance from each set to the next. So you're showing not only high force output, but the ability to maintain that force output for longer periods, which is exactly what we want from performance. Okay? And of course, please be careful with body weight versus free weights, one thing being better than another, machines versus free weights. It's very specific to the motion you're looking for. If a machine can mimic the same motion you're looking for, the machine is fine and nothing wrong with that. You don't graduate past machines. It's very specific to the motion you need. And if you can't mimic the motion properly within a machine's utilization, then you don't use that machine. Free weights are not something you do after you've maximized body weight training. A lot of you have said that before, and I've tried to help you understand how that's not the same thing. First of all, lower body weight training is easier than having lower body loaded training. A bodyweight squat is easier than putting a bar on my back or holding dumbbells at my sides or something like that for a lower body strength exercise. Upper body, push-ups, pull-ups, things like walking on your hands, stuff we do on our hands, body rotations, things like that, all the kind of stuff you do on your hands, it's actually much more difficult than picking up a 5, 8, 3-pound, 10-pound, 15-pound dumbbell and pressing it over and over again from our chest or pulling down a bar at 40, 50, 60 pounds, somewhere in there for almost all human beings. Loaded exercise externally is often easier with upper body than body weight. Don't say body weight first. Nope. Find specific to the person's needs. Be careful with generalizations. We've all done this. And can you combine strength and endurance type training? Can you get maximally powerful and maximal endurance? No. Can't. Shouldn't surprise you. You're not going to have Usain Bolt's not going to become the best marathon runner. I'd put everything in my career on that. He will never run a sub, maybe if he's lucky, a sub 3 hour. He's an athlete, but I doubt that even 3 hours. He might. Okay. Sub 2.5 hours? No. Sub 2 hours? I'd bet my life on it. There's just no way. You don't see someone at that performance level be able to duplicate it at the extremes of another. Can you get combinations? Absolutely. And there are athletes who have done this, but not at the highest levels of elite levels of performance. There's only so much combination you can get. You have no choice in certain sports that require power and endurance, speed, strength, and strength endurance or glycolytic response. In those types of sports, you have to combine training, but you also have to understand that every time you focus on one thing, you're giving up something someplace else. And that is just the way it is. And it's just the way it has to be, which is why we have to always be thinking about which is our primary goal now. And that's what you focus on. Okay? And of course, soreness is never a good thing, ever. Are you sore? Good. No, it's not a good thing. It either means there's something lacking in one of those 4 factors we talked about. Not enough sleep, not proper nutrition, too much life stress, or too much exercise / too little rest between sets, or too high of a frequency in exercise, wrong types or tools of exercise. Any of those fitter variables when it comes to exercise is off. We don't want stiffness. We don't want soreness, period. Best case scenario, athlete goes through a high-level training session, does a proper recovery between the session, as well as a proper cool down and the right level of training during the session, even though it was very difficult and they had that blood pooling and basically that burning sensation during the training, felt a little bloated during the training. By the time the cool down is done, they don't feel that anymore. A little tired, but not too bad. Good night's rest. Come back next day to work out. They're not quite that level of maximal performance again, but certainly not sore or stiff. Okay? That said, that's what our goal is. Post-exercise muscle soreness is stiffness or soreness really within a 24-hour period. Closer to 48-hour period is more toward delayed onset muscle soreness, and neither of those is a good thing. The longer the soreness and stiffness goes on, the worse the person's adapting and recovering. The worse they're adapting and recovering, the lower performance improvement we are getting. Okay? That said, our final point, off-season wise, the primary focus point should be once the season ends, like effectively for NBA players right now, or college basketball players, or winter sport players in general, or volleyball kind of coming down for some levels, seeing volleyball come down to that point, or soccer at some winter level. Some areas, soccer is a winter sport, or ice hockey, you name it. They're in their off-season. Focus now on movement skill. Get your flexibility, your mobility going, your motor control, your coordination, movement skill, low levels of strength building up now, and basic endurance. Okay, and of course for preseason, we get within like about 2 or 3 months of your first game or first competition. That's when we start focusing more on trying to increase the maximal capacity of our whatever performance parameters we're looking at, your strength, your speed, your power, your endurance, whatever it is. And of course, in season, we're really trying to maintain your performance and sharpen. When we say sharpen, getting you ready for that primary competition we're looking at. We're looking at in season, when we're now into the situation where you're less worried about conditioning. Your primary goal is, you believe, based on what you see and what you're getting from your athletes, let's just maintain where we are now. If you're still looking to see improvement, you got to allow at least that 8 weeks, 2 months, before you start seeing any major benefits from what you're doing now. Keep that in mind when we talk about tapering or winding down their level of intensity with their athletes, or the volume of training coming down, or allowing more rest, what have you. Within you start getting within 8 weeks of your major competition, you got to be thinking about how to alter programming to once in a while have a fairly challenging type session to make sure the person still got it, or the athletes still have it and can handle that capacity. But ultimately, you're trying to sharpen them, getting them ready for that big competition, not expecting to see performance gains at this point. Okay. That said, final thoughts for those of you in the course. Performance plan in your posts. Make sure you're now noting to some extent. I'm going to start getting after you these last few weeks. How often are you doing this? What's your intensity? What are you doing when you're doing this? Roughly speaking, not the exact perfect description of the exercise, so I know exactly what you're doing, but at least roughly. Of course, the time duration it's occurring in, the rest period, all that needs to be there. I will ask you. Week 11 coming up here in the next couple weeks. as our final exam. You're now past everything but doing Learn Smarts and your discussion board posts every week until that last week. That last exam is worth 2.5 times the other exams. It's a final exam point-wise, but it's non-cumulative. Okay? That said, call or email them if you have questions. You're all doing a very good job, extremely good job with your posts and keeping up with the information and the material. I greatly appreciate your efforts, and I'm very impressed by what you're putting out there. And you'll note that even when I give you criticism and I come after you a little bit on certain points, I don't take away from your points based upon that, but I am going to get after you in terms of how you apply that in your later days and months and the years post this class. Look forward to talking to you again soon.